Water is essential to life's existence. Our bodies must be replenished every day. Water is responsible for the energy we need. In addition to growing our food, it stimulates the plant life, which produces the oxygen we need to breathe. Welcome to the University of Idaho. Like all college campuses, we utilize water resources every day to maintain year-round activities. Water is essential for student housing, recreation, research, landscape maintenance, fire protection, food processing, and building comfort. We will talk about where our water comes from, how well it travels through our systems, our methods of conservation, and moving forward with our goals. Our university receives water from two sources. The Wanapum Aquifer is used for research applications on campus. The Grand Ronde Aquifer, which lies below the Wanapum, is the source of the university's drinking water. Although the aquifer contains a vast amount of water, soil research suggests that little precipitation penetrates the water table, indicating the aquifer is confined by some layer of rock or soil. As a result, the water level was declining at a rate of 1 to 2 feet per year since measurements began in the 1930s. Recent studies have shown that thanks to the combined efforts of entities pumping from the aquifer, the declining rate is now half a foot each year. Due to insufficient surface water access, the aquifers are the sole supply of water for the 60,000 residents and both universities on the Palouse. Reducing water usage ensures the aquifer remains a resource for generations to come. As the chart shows, out of all the aquifer users on the Palouse, the U of I only accounts for 6% of the total pumping from the aquifer. Digging deeper into U of I's resource distribution, we can see the water profile reflecting beneficial uses of water. Supporting applications from domestic water consumption to fisheries research, we are continuously taking steps to minimize our impact on the resource. The university has 2 deep water wells supplied from the Grand Ronde Aquifer. Pumping through underground pipes up to 2 storage tanks provides campus with a steady supply of potable water at a constant pressure. The I-tank, installed in 1951, is the oldest water tower on campus and holds about 500,000 gallons of water. The second tank was installed in 1979 on the golf course and holds 2 million gallons of water. Combined, these tanks can supply campus with drinking water for about 3 days. The university's newest tank was constructed in 2009. Holding over 2 million gallons of chilled water, this tank supplies cooling for many of the core campus buildings. Overall, the university provides 153 million gallons each year of potable and recreational water to the campus for everyone to enjoy. Water is tested regularly to ensure it meets health and research standards. The Aquaculture Research Lab relies on water from the Wanapum for essential operations. Here, thousands of fish are raised in specialized water tanks for research applications. The system that runs the water must be closely monitored and maintained so conditions are suitable for fish growth and their very specific living requirements. Aquaculture requires a large supply of natural water for continued operation, but ultra-pure deionized water is used for almost all other research on campus. Recirculating systems at the laboratories allows water to be filtered, aerated, chilled, and reused to maximize the potential of every gallon. Other conservation efforts and system improvements have reduced annual water use by 10 million gallons, a 77% decrease in water since 2005. In addition to recreational and research use of water on campus, industrial processed water is another part of our system. Processed water describes the water used in the heating and cooling of buildings needed to ensure a comfortable environment year-round. Heating systems utilize water in the form of steam that is distributed to over 60 buildings through the underground tunnels. The cooling system is similar, but instead of using steam, chilled water is used. The chilled water system is treated with a combination of biocides and corrosion inhibitors to increase the number of passes it can make through a cooling tower. This means that we can run the same water through the cooling tower more times with treatment. This reduces the need for makeup water and ultimately saves a significant amount of water each year. We are continuously trying to minimize losses to our industrial processed water system. For steam, it is important to utilize the purest water available. Water pumped from the aquifer is softened to remove calcium, magnesium, and other metal cations that may be present in raw aquifer water. If the water is not treated, these contaminants will precipitate out of the water when it is converted to steam, and they will have the potential to scale and block boiler tubes, causing inefficiencies to the system. Once the steam gives off its heat energy, it cools, condenses, and returns to the steam plant to be reused. Some water and energy is lost in the process, but improvements over time have resulted in a 97% condensate return rate, saving 6.5 million gallons of water per year. The U of I has saved water and money by improving conservation methods. For the last 10 years, an aggressive campaign of system maintenance has been implemented to fix faulty steam traps and identify leaks present in the system. This has resulted in a significant reduction in water loss from the steam and chilled water distribution systems. In addition to our maintenance campaign, low-flow fixtures such as toilets, faucets, and shower heads have been installed to minimize water consumption. Our newest facility, the Integrated Research and Innovation Center, or IRIC, is equipped with a green roof and a stormwater collection system. The green roof is planted with native vegetation that requires minimal care, and the stormwater system creates a source of sustainable water. The stormwater catch basin has a volume of 26,000 gallons and waters an array of trees, native grasses, and landscaping plants around the building. A large part of our conservation efforts relies on the processing of wastewater. Post-consumer wastewater is collected in the sewer system and then flows to the City of Moscow water treatment facility. There, wastewater from campus and the City of Moscow is converted from the unsanitary gray water into clean, reused water. The conversion process utilizes waste-consuming microorganisms that break down and reduce the phosphorus content of the influent wastewater. This mixed solution is allowed to settle for sludge removal as a biosolid. The remaining water is filtered for sludge and additional particles, re-aerated, disinfected via chlorination, and finally declared sanitary. About 86 million gallons of water is pumped back to the university each year and reclaimed as non-potable irrigation water. This is 86 million gallons of water that is not pumped off of the aquifer. The City of Moscow and the University of Idaho have been diligently working together to bring a vision of sustainable practices to the community. Since its commissioning in 1978, the reclaimed water system has saved about 2.6 billion gallons of water. It takes over 68 miles of pipe to irrigate about 200 acres of landscaping on the U of I campus. Xeriscaping is a method of landscaping that requires little or no water. Applications of xeriscaping can be seen in the Living Learning Center, Arboretum, Botanical Garden, and the IRIC building. The University of Idaho uses mostly low-impact reclaimed water for irrigation and implements sustainable landscape practices. By planting native grass species and avoiding the use of annual plants, we help preserve the remaining 1% of native Palouse landscape while saving water. The University of Idaho Sustainability Center provides invaluable support on the social front by encouraging students to participate in water conservation practices. Each year, the Sustainability Center leadership emphasizes one environmental issue and develops a year-long campaign designed to create an active culture of sustainability. Through their water conservation initiatives, competitions, and other special events, students more than ever have become a part of the community-wide effort to reduce our impact on the water supply. Community efforts have established the Palouse Basin Aquifer Committee, or PBAC. PBAC is an organization made up of 6 municipal and educational entities on the Palouse. Their mission is to ensure a long-term, quality water supply for the Palouse Basin region. As a member of this organization, the University of Idaho works to raise awareness about the water supply and help implement solutions to mitigate excess water usage. Historically, the university's water use peaked in 1987, but today, aquifer use has been cut in half thanks to the conservation efforts. These levels haven't been observed since 1955, even though we currently have twice the student population. All in all, the University of Idaho provides water resources to students, faculty, and staff through a variety of sustainable systems. This allows for a comfortable, productive, and aesthetically pleasing campus environment. The water savings efforts do not stop here. While implementing critical water-saving measures to conserve our aquifers, and with help from consumers across campus, we can save money and our precious water supply for a more sustainable future.